Welcome to homework.
So here in this problem we are given that a piston cylinder device, it contains 5 kg of steam. So mass we are given as 5 kg and the quality of the steam is 50 percentage. So we can say that x1 will be 0.5 and the steam undergoes two processes, as you can see in the TS diagram also. In the first process 1 to 2, heat is transferred to the steam in reversible manner and the temperature is remains at constant, that is 100 degrees Celsius, and it reaches to saturated vapor. Now in the process 2 to 3, heat expands in an adiabatic reversible process till the pressure reaches to 15 kilopascal. And there are three parts in the equation. In the A part we have to sketch the TS diagram. As you can see, I have already drawn this is TS diagram. And in the B part we have to find the heat transferred in the process 1 to 2, and in the third part we have to calculate the work done by the steam in the process 2 to 3. So A part we have already drawn, that this is a TS diagram, and the process this represents the process 1 to 2 and then finally 2 to 3, and these are constant pressure lines, and the temperature remains constant at 100 degrees Celsius from the process when the steam when the heat is transferred to the steam from the process 1 to 2, and then finally the pressure reaches to 15 kilopascal in the pressure in the process 2 to 3. Now next we'll be solving the B part of the problem, in which we have to calculate the heat transfer. So for that we'll be using the table A4 and A6 to find the required input data. So at state 1, T1 is 100 degrees Celsius and dryness fraction, that is X1, is 0.5. So by using the table as per given in the book, we can calculate the value of H1 from here, and H1 will be HF plus X times HFG. So by this formula we can calculate the specific enthalpy at state 1. So we have to plug all the values here. HF from the table will be 419.17 kilojoule over kg, plus the dryness fraction we are given as 0.5 times the HFG from the table will be 2256.4 kilojoule over kg. So after solving this, we'll get the value of H1 as approximately 1547.4 kilojoule over kg. So next we will be calculating the properties at state 2. So T2 we are given as 100 degrees Celsius, and the dryness fraction X2, it reaches to 1 because it is saturated vapor. That is why the quality of the steam will be 1. So at this state we'll be calculating the properties H2, U2 and S2. So H2 will be equals to Hg, because at this point H2 is nothing but Hg. So Hg from the table will be 2675.6 kilojoule over kg, and U2 will also be Ug. So Ug from the table will be 2506.0 kilojoule over kg. Similarly S2 will be equals to Sg, and it will be 7.3542 kilojoule over kg. And next we'll be calculating the properties at state 3, that is P3 we are given as it's 15 kilopascal, and here since the process is isentropic, so S2 will be equals to S3. So S3 will be 7.3542, and here we have to calculate the value of specific internal energy U3. So U3 will be equals to UF plus X3 times UFG. So first we have to calculate the value of X3. So X3 will be equals to S2 minus SF divided by SFG, and all these values will corresponding to this pressure 15 kilopascal. So S2 we have calculated as 7.3542 minus SF from the table A5 corresponding to 15 kilopascal will be 0.7549. Divide by SFG from the same table will be 7.2522. So after solving this, we'll get the value of x3 as 0.9099. Now we can calculate the value of U3. So U3, the specific internal energy will be UF. So UF from the table A5 corresponding to pressure 15 kilopascal will be 225.93 plus x3 is 0.999 times UFG is 222.1. So we're going to solve this and we'll get the value of U3 as 2247.9 kilojoule over kg. So we have calculated the value of U3 also. Now we can calculate the heat transferred in the process 1 to 2, that is Q1 to 2, and Q1 to 2 will be equals to the formula M times H2 minus H1. We obtain this equation by using the energy balance for the closed system, that is E in minus E out is equals to change in energy of the system, and that equation reduces to this form for the process 1 to 2. Now we have all the values here, we can plug it here to calculate the value of Q1 to 2. So M we are given as 5 kg times H2 we have obtained as 2675.6 kilojoule over kg minus H1 we have 1547.4 kilojoule over kg. So after solving this, we'll get the value of Q1 to 2 as 5641 kilojoule. So we have obtained the value of Q1 to 2. Now next I will be solving the C part of the problem. Now in the C part we have to calculate the work produced, that is W2 to 3 work output in the process 2 to 3. So work output will be M times U2 minus U3. So we have all the values here, we can plug it all the values in this formula. So M we have 5 kg times U2 we have 2506 kilojoule over kg minus U3 we have 2247.9 kilojoule per kg. So after solving this, we'll get the value of work produced as 1291 kilojoule. So this is the final answer for the C part. So I hope you got the problem. Thank you.